All right, so in this video, we're going to walk through the process of solving a linear inequality. Now, this one is a little tricky because it does involve fractions, but the process is basically the same as we would do in any other scenario. Now, the first thing that we can do is we can combine these constants. We have -3/4 and -1. And so if I add these together, this is going to be 4/4, -3/4 minus 4/4. This is going to end up being -7/4 when we're all said and done. All right, so now we want to try to get rid of all of our fractions to make our life much easier because nobody likes working with fractions. Even people who can work with fractions, it is slower and harder to do, requires more mental effort than working with whole numbers. So clearing the fractions is always a good strategy. Now, our common denominator here, we've got 3, 4, and 2. The common denominator is going to be 12. So I'm going to take every one of these terms and I'm going to multiply by 12, essentially 12/1. And again, every term gets multiplied. Now we're going to simplify where we can. So our next line, 3 and 12 are going to partially cancel and leave a 4 to multiply the x. The denominator is gone because it's just 1. In our next case, 4 is going to cancel partially with the 12 and leave a 3. Again, 1 in the denominator. So 3 times 7 is 21. And then 2 is going to partially cancel with the 12 and leave a 6. So that leaves me with a 6x. Now, since I'm not multiplying by a negative number, I don't have to worry about flipping the inequality or anything. Now, again, typically, we're going to try to get x on one side and the constant on the other. I can subtract 6x from both sides. So 4x minus 21 minus 6x is going to be 6x minus 6x. Combining like terms, 6x minus 6x is 0. And then I'm going to add 21 to the other side, or to both sides technically. 21 greater than 0 plus 21. The 21s are going to cancel on the left side, and I'm going to be left with this. Now is where I have to be careful. If I divide by a negative, I do have to flip the inequality. So -2x divided by -2 is going to be x less than, not greater than anymore, -21/2. Now, keep in mind that I ultimately want to draw this on a number line, write an interval notation. Sometimes I find that it's easier to draw it first and then convert it to interval notation, particularly when there's, if there's 2 endpoints, it's not that bad. But if there's only 1 endpoint, sometimes that can be a little bit more confusing. So I'm going to draw, and you're going to have to forgive my bad penmanship on the video because I'm not used to drawing on the computer. So that's not a great straight line, but you get the idea. Where my midpoint is doesn't really matter. I can put it any place I like. So -21/2. Now, I want x to be less than that, which means it's going to go in this direction, like so. And there's no other endpoint, so it just goes all the way down to -infinity. I do need to label my endpoint to indicate whether this 21/2, -21/2 is included or not. And the way that we're going to do that, I'm going to change colors just so that it shows up more easily, is you can either do an open circle like so, to indicate that that is not included. The other way that you can indicate that is to use a round parentheses, like so. Now, both of these are going to indicate that the negative 21 over 2 is not included because there's no equal sign here. Now, one advantage of the open dot is that this is consistent when you try to draw piecewise graphs, so there's a connection there. But the parentheses is consistent with interval notation. And since I'm going to do that next, I'm going to use the parentheses in my final answer. Negative infinity is never going to get a square bracket, never ever, because infinity is not a number. It is like it is like a direction. You're going forever. You're not ever getting there. So it can't ever be included in the interval. But for the negative 21 over 2, that could be included or not included. But in this particular case, because it's strictly less than, it is not included. So we would write 21 over 2, and then the parentheses, not the square bracket, is going to indicate that it is up to but not including that value. And so that is our interval notation.